Hello and welcome to another wonderful day of physics. Today we're going to be using our platform, like I had earlier told us that henceforth we're going to be using our platform to learn. Okay, so I'm going to quickly open to the topic we are going to be looking at today. And this is the platform educateafricans.com. So just head on to your phone, to your browser, just put educateafricans.com. You'll be open to this. So once you're done, you can scroll down, see the different subjects, economics, English, and the rest of them. So click on view all courses, because we are going to be going to physics. And that's why I've clicked on view all courses, because I want to get to physics. So you're going to see how very fast you can cover a whole lot if you're using this platform. Because in this platform, we just looked at the most important of the topics. It's not everything, just the most important according to your syllabus. Okay, so you can see other courses, CRS, literature, and the rest. Okay, chemistry. Okay, this is where we are looking. This is physics. You can see this very physics. There are lots of other physics on the platform, but this is the physics we are going to be working on. See this one uploaded by Zimozo Uzechina. That's the one we're working on. There are other physics, because this is a marketplace for teachers to create courses. So you can see other physics, but I will always tell you the one that we're using to learn. So I'm going to click on this one. Okay. So like I said, every student is supposed to come to this website and create an account. Once you create an account as a student, so that you can be able to do the assignment. I'm going to be giving assignments after each lecture. And this is where you can click student registration and quickly register, so that when I give an assignment, you should be able to do it. So once you click, you can click on enroll. I've already enrolled. That's why I can see start course. Okay. So if you scroll down, you're going to see all the topics: measurement, dimension, application, units, multiples and submultiples, vernier calipers, microscope, all the things you have in your JAMB is there. Video lectures, good video lectures. Okay. So I'm going to click on start course. That's what you click here, start course. Okay. So once you click on start course, it opens up. You can see this is the first lecture there, Introduction to Physics and Measurement. You see, it's a video format. You can play the video in your house. You enjoy it. Why I have to do this? This will make you to learn faster. You can see, starting from Introduction to Physics, what physics is all about. If you scroll down, you see measurement and derived units, fundamental units. Physics is the natural science that involves the study of matter and its motion through space and time, along with related concepts such as energy force. Physics is a pure science that deals with the behavior of matter, energy, and how it relates. Examples of everyday living in physics: driving, lightning, thermometer, camera. You see? So this is according to your syllabus. We've already covered all this. You went into measurement, the different measuring apparatus, a micrometer, screw gauge, ruler, and their measuring accuracy is very important. These ones always come out in your JAMB exam. They will ask you, meter rule can measure to what accuracy? 0.1 cm or 1 millimeter. Vernier caliper, 0.1 millimeter or 0.01 cm. Micrometer screw gauge, 0.01 millimeter or 0.001 cm. So this micrometer screw gauge measures to the minutest of length. Beam balance 0.001 gram and stopwatch 0.1 seconds. Okay, so this fact is very, very important. You're always going to see this in your exams, and you're always going to also see all these measurement instruments. They are already listed here. Meter rule, this is a meter rule. Vernier caliper, this is a vernier caliper. Micrometer screw gauge, this is a micrometer screw gauge. Beam balance, this is your beam balance. Stopwatch, this is your stopwatch. So all of them, both in diagram form. And that is why this is where you're going to be learning. This is the video format. If you play this video now, you see me in class. I'm in class giving you the same thing. So this is what you need for you to pass. So this is the first course, measurements. We started everything according to your syllabus. So I was flipping through the syllabus while I was making all these courses. So take note. If you finish measurement, the next thing is dimension. And you see the quiz. This quiz is from your JAMB past questions. And after the quiz, you see the quiz explanation showing you how I solved all these JAMB past questions. So very, very important. This is what you're going to be using. So for those of us that are joining us for the first time today, quickly go to the website. The name of the website is educateafricans.com. Once you go there, click on the physics by Uzechina Zemozo. That's the one we are using to learn. So very important. So you see all the fundamental quantities. Length is meter, time is in seconds, mass is in kilogram, electrical current is in ampere, temperature is in Kelvin, amount of substance is in mole. So JAMB is going to ask you which of the following is not a fundamental unit. They will write length, time, mass, and they will now put density. You should know that density is the derived quantity. So these are the derived quantities. These are the fundamental quantities. All these ones are the derived. So you have these lectures in both video format. This is the video format, the same thing that is explained in the text format. So it is curated for you. Then once you're done, you will now solve the past questions by clicking on this JAMB physics past question. So once you click here, you will be, okay, let me click there so that I'll show you. Okay, you'll see this start quiz. You click on it. Once you click on it, it will start asking you questions based on what you've learned already. So with that, you're able to see the similar, okay, the dimension of power is, you can see now. So you have to solve. Once you solve, you pick an answer, you click on next question. So once you're done, you click on this quiz explanation and solution in case if you don't understand how to solve it. So we've already solved it again for you here as well under quiz explanation and solution. So I'm going to click on it, it will open, okay? So that has opened now. So you see the way it was solved, the dimension of power. Power is equal to work over time, which is equal to force times distance over time. Then you sort it out to get this as your answer. And this one, what is the least possible error for meter rule? We all know from this thing. So meter rule is an instrument used to measure length. You can see that the least possible error is 1.0 millimeter. So this is the solved problem already, similar to what you see in the quiz. So we've taken our time and we are continuing to work on this. We've not finished our work on this. We just started, but I want you to start using it so that you will be able to, you can also criticize us so that we know what to improve on it. So very importantly, that's where if you use this in 2 days or 3 days, you can cover your whole syllabus in physics. Then you continue again, study all over and over. That's the constant drill that we want people that have been trained by Tclassified.com or Educate Africans. We want you to constantly go through your stuff so that you become a master. We want you to become a master of what you're doing. Because we want you to score 300 and above in your JAMB and 9A1. The only way to do this is by making sure that you've gone to our website, educateafricans.com, cover all the syllables immediately. Don't take much time. Cover them, start them again, cover them again. That's the only way you can do that. And like I said, all your JAMB past questions, we've already summarized them here. so that as you're solving the topic, once you're finished learning, once you're done learning the concept, you'll be able to solve all the past questions immediately. So by so doing, it's so perfect way to learn. So like I said, this is the first topic in your syllabus is measurement. And we did this according to your syllabus. So this is the video. You can play the video. It's me that is also teaching in the video. So once you play the video, it's very, very interesting. It will tell you what physics is. All these explanations I'm giving you, they're already there. You hear it very clearly. Then if you read the text, fundamental units, derived units, everything you need. So once you're done, you do the quiz. So with that said, we're going to start today's topic. So what we're going to be doing today, we'll be able to use this platform and cover 3 to 4 topics today alone. Because I want us to be able to cover everything before the end of the month. We've covered all our syllables for all the subjects. And that's why you must be using this platform. This platform is the only platform that can enable us to cover so fast and be able to revise, take fast questions, and get ready.
Let me see. Wait first. I don't see. Please direct me.
Who is on Galaxy 809? Mute yourself. I don't want people to be disturbing us while we are learning. Okay. Oluwase, please confirm that you guys can hear me very well because it's raining heavily over here.
Sir, we can hear you, sir.
Okay, thank you. So I hope you understood what I was saying, Oluwase. I was explaining how to use this our new platform. This is our new platform. The name is educateafricans.com. That's where you people, we've already loaded all the video lectures and everything there. So you guys can go there, start taking lectures. Make sure you register as a student so that when I give assignment, once you go and do this quiz now, if you click on this quiz under dimension, once you finish answering, I will see your answer from here. Here that I am. Once I log in, I'll see all my students. Everybody, or like Oluwase, all of you that have registered Chika, I have all your details already. So any assignment I'm giving now will be the quiz. So once you do the quiz, I'll go there and check how you scored, see the ones you failed. Then if you have any questions after trying out any of the quiz, maybe you don't understand anything here, can you see this place they wrote browse Q&A? You click on it, browse Q&A. Once you click on it, you scroll down to ask questions. If your question is about motion, you don't type in for me motion. So once you type motion, you now type the question here. So you can ask me, what is the difference between circular motion and circular motion and random motion? So you must make sure you put a topic there, then you put it up. So once you put it up, you can click on submit question. I will get it from here. My teachers will also get it and ask. So that is how, even if you have an assignment, that's how you're going to be pushing your assignments henceforth to us, so that we can see them easily and take care of them. Because we want to be using this platform to interact with all our students, because we organize it in such a way that it will be easier for you to learn with it. Okay, so let's go to what we have for today. So welcome to this our platform. Like I said, from today, that's what we are going to be using. So there are lots of physics lectures on the platform. The one I say you should use, make sure you're using the one done by Zimus or Ozechine. JAMB physics, JAMB WAEC physics. So that's the one we are using. Okay, so let me go to the topic we have today. I'm going to a topic that we newly put in that doesn't have video, so that we can use this video that we're arranging as a video. Okay, so you can see we want to cover from here down here. We want to cover like 3 topics today: simple machine, work energy and power, centripetal and centrifugal force, and finally elasticity. So at the end of this class, I want everybody to go to these 4 last courses, do all the quizzes. Like I said, all the quizzes are from your JAMB past questions and your WAEC. So as you're doing them, it's as if you're already revising your past questions. So that is the assignment. I'm declaring this assignment before I start the class. Assignment is simple machine, work energy and power, centrifugal and centrifugal force, and elasticity. So 4 given assignments for you guys to do. So once I'm done with this class, I'm going to log in. From now till tomorrow morning, I want to make sure that everybody must have submitted your own assignment. When I go there, I see it. We are not going to be working with students that are not very serious. If you're not serious, you're not supposed to be with us because you will not be able to meet the mark that we want for our students. 300 and above, 9A1. For you to get that, you have to be working. And how do you work? You follow the class, do the assignments that I give you, rewatch these videos. These videos, they're always on our YouTube channel, and we're also sharing them on the special WhatsApp group. So I'll be, from henceforth, I'll be sharing the videos on our special group WhatsApp. If you're not in the special group WhatsApp, after this lecture, chat me up. Tell me you want to join the special group WhatsApp. Very simple donation, you can join it. Those are the people who take very care of because they are our students, okay? So I'm going to click on this simple machine. Click on this one that is inside because that's what we're going to be learning today. So once I click on it, I'm going to scroll up. And I hope that you guys have all downloaded our app, the app for the JAMB application for your JAMB Pass question. The name of the app is Educate Africans. Go to Google Play Store. Just type in Educate Africans. You see that app is so cute, especially meant for you to score your 300 and above. Once you download it, if you have any difficulty in trying to license it and everything, chat me up on my WhatsApp. All of you have my number already. Okay. So today, let's start what we are learning today. Today, we're going to be looking at simple machines. Very, very important. If you have your notes, make sure you're taking down notes. This is your live class. Take down notes. Make sure you're copying something. A student that does not copy notes is not a student. A student that does not copy notes is not a student. Because if you're a student, you copy notes. When the teacher is not there, that note is your reference material. That's what you look at, and you're able to now recover everything that has been taught in the class. So whenever we're having a class like this, you must have your notes and you must be taking that note. So what is a simple machine? A simple machine is a device or tool which allows a force applied at one point to overcome a resisting force at another point. So you apply force at one point and it's overcoming a force at another point. Take for instance your wheelbarrow. If you have your wheelbarrow, this is how you carry your wheelbarrow. You're holding your wheelbarrow here, but your wheelbarrow is carrying a very big load that you wouldn't have been able to carry on your own. So you apply a small force and you're able to carry a big load. So that your wheelbarrow is a simple machine. And that's why you can see here, among the examples of simple machine, you can see wheelbarrow here. You can see a nut cracker. Your nut cracker, once you press like this, it cracks the nut. If you're using your hand to crack the nut, you cannot be able to crack it. But once you press the support of that your nut crack, it cracks the nut very easy. Your plier, if you want to remove a nail, if you use your hand and you're trying to remove a nail, it will be so difficult you cannot remove. But just put a plier and just place the support like this, chicken, the nail will just go out. So all those devices, all those tools that help you to solve bigger problems that you wouldn't have been able to do with your hand, they are known as simple machine. Are we clear on that? Oluwaseyi, am I clear on this? Choma, am I clear?
Yes, sir, you're clear.
Okay, so let's move forward. So a machine allows you to overcome a large resistance or load by applying small effort. So once you apply a very small effort, you're able to carry big load. That's what a simple machine does for you. So what are the examples of a simple machine? JAMB is going to ask you, which of the following is not an example of a simple machine? So you're supposed to know what simple machines are. You're supposed to know the examples. If not, when you see them, you will not be able to recognize them when you're asked in your WAEC or your JAMB. Make sure you know that what you are covering here in your JAMB is also what you also have in your WAEC. So as you're taking the class, you're covering both sides. So good examples of simple machines are levers, pulleys, pliers, wheelbarrow, nut crackers, inclined plane, wedge, wheel and axle, screw jack. So all these are examples of simple machine. Now we're going to be looking at some important terms that are associated with simple machine that you need to know as a student because they will always come out in your JAMB. And those terms are: one, mechanical advantage. You need to know what it is. Velocity ratio, you need to know what it is. And you need to also know how to use them in doing calculations. Are we clear on that? Okay, let's move forward, okay? So what is mechanical advantage, MA? We repeated them, that's why I'm scrolling down, okay? So what is mechanical advantage? I hope the notes is clear. You guys can see them very well from there. Oluwaseyi, Buchi, can you see the notes that I'm scrolling? Buchi, can you guys see these notes clearly?
Yes, sir, we can see.
Okay, so let's continue. So what is mechanical advantage? Effort is the force applied to a machine. So that force that you apply, you that is pushing the machine, is known as effort. Take note. Effort in a simple machine is simply the force that you're applying as you're pushing your nutcracker, as you're holding your wheelbarrow and pushing it. That force you're applying as a person is known as effort. Whereas load is the force resistance that you overcome. Load is that thing that you're carrying inside the pan of your wheelbarrow. Load is that nut that you're cracking. Load is that what's it called? That nail that you're removing from where it is. All those ones are known as load, and we call them resistance. So we say that load is the force resistance overcome by the machine. So now, what is mechanical advantage? Mechanical advantage is the ability of a machine to overcome a large load through a small effort. The ability of a machine to overcome a large load through applying of a very small effort. That is what we call mechanical advantage. So I'm going to ask somebody now. Let me see what I'm going to add. Chika, it's like you're just joining.
Yes, sir. Sorry.
Please, you have to watch this video. I've said it a whole lot. Please, you need to be joining in time. I don't want you to be joining late. So Oluwaseyi, help us. What is mechanical advantage? And when you're answering, I want you to shout it so that I can hear you very well.
Mechanical advantage is the ability of a machine to overcome a large load through a small effort.
Perfect. Choma, what is differentiate between an effort and a load, Choma?
So a load is the output force, while an effort is the input force.
Perfect. The load is the output, what you are able to achieve, whereas the effort is what you impute, the effort you're giving. Stephen, what is the formula for mechanical advantage?
So sorry, I'm just joining.
Yeah, no problem. We've not covered so much. We started with what a simple machine is. I would say that a simple machine is simply any machine that enables you to overcome a large load or large resistance using a small effort. Okay. So class, pay attention. This is the formula of mechanical advantage. Please, this is MA, it's not IA. MA is equal to load over effort. Very, very simple calculation. Load over effort. Please, everybody should mute him or herself. Mute yourself, everybody. I don't want to have in everybody. Chidera, you're not muting yourself. Yeah, good. Okay, so let's continue. So this is the formula for a mechanical advantage, load over effort, and it's simply output force over input force, just like Buchi told us. So this is the formula. Take note of this formula. You're going to see it. You're always going to see them in your WAEC. You're going to see them in your JAMB. So make sure you pay attention to them, okay? Now, mechanical advantage of a machine is influenced by friction in the parts. Parts of the effort applied will be used to overcome friction. So a machine that has no friction is an ideal or perfect machine. JAMB is going to ask you, what is an ideal machine? What is a perfect machine? An ideal machine is that machine that does not have friction. Are we clear on that? Any machine that does not have friction, that means that all the efforts that you apply will be used in overcoming the load. None of the efforts will be given to the friction. So that is a perfect ideal machine. Now let's go to the next topic, velocity ratio. Mute yourself. Oh, who is that person talking and is not muting him or herself? it together. So let's continue. So let's look at the next second concept under simple machine, velocity ratio. Very, very importantly, what is velocity ratio? So velocity ratio is the distance moved by effort all over distance moved by load. So take note, in mechanical advantage, the load is on top, the effort is down. Whereas in velocity ratio, the effort is on top, the load is down. So take note of, there are simple things that enable you to quickly memorize a formula in physics or sciences that will enable you to make a better outcome. So velocity ratio depends on the geometry of the machine and it is independent of friction. Velocity ratio does not depend on friction. We know that mechanical advantage depends on friction, but velocity ratio does not depend on friction. And for an ideal machine, mechanical advantage is always equal to velocity ratio. Now, efficiency, very, very important. You will always calculate efficiency. And efficiency is simply the work done by the machine over work put into the machine. So the output that the machine is able to give all over the input times 100 over 1, that is your velocity, that is your efficiency. And you can also say that it is equal to mechanical advantage all over velocity ratio times 100 over 1. So take note of that. Take note of that. Very, very important. So if you're asked, why is it that machines are not always having 100% efficiency? Who can answer that in this class? Why are machines not having 100% efficiency? Who can help us with that? So machines are not always having 100% efficiency because always some part of the efforts are always used in overcoming friction, okay? So these are the different formulas for velocity ratio for an inclined plane, velocity ratio for a screw jack, velocity ratio for wheel and axle, and always in the absence of friction, mechanical advantage is always equal to velocity ratio. And like I said, friction reduces efficiency. It's because of friction that machines are not always having 100% efficiency. And efficiency is always equal to work done by machine all over work done in the machine times 100 over 1. So with that, we'll cover these basic concepts in a simple machine. So for those of us joining us, we said that from today henceforth, we are going to be using our platform, and the name of the platform is Educate Africans. If you watch this video from start, you see how we got to this place. Once you get to Educate Africans, you will see the physics JAMB WAEC. You click on it, it will open up this. And like I said, we've already prepared the course according to your syllabus. To help you can see, we started with introduction to physics, measurement, dimension, examples in dimension, applications in dimension, units, calipers, various micrometer, screw gauge, motion. All these topics, we've covered them already in our online class. But here, we have already put them. Both the videos and the quizzes are from your past questions. So that's what we are using now. Immediately after this class, I expect all of you that joined this class to go and do the quiz that follows these 4 topics we are looking at. And the 4 topics we are looking at are the last 4 topics we just filled in. Number 1 is simple machine, which we just finished. So we are going to work energy and power. After that, we look at centripetal and centrifugal for an elasticity. So we are covering 4 topics in one day. And we can only be able to do this because we are working with this educateafricans.com. If we are using other means, we wouldn't have been able to cover this. And that is why this is the best platform for you. All my engineers and teachers, they are constantly working on this platform, Educate Africans. They are sieving it, making sure that the only things you have here are things that are directly affecting your JAMB and your WAEC. So please start using them. So I'll click on work energy and power now. You can see after this work energy and power, this is the quiz. So I expect you to answer this quiz and I'll be watching to see who gets the highest answer. So let me click on this work energy and power. Then I'll scroll up so that we can have it. Okay. So let's start immediately. So you can see that we've already covered one topic, simple machine. Do the past questions immediately. That one does not have quiz now, but we are updating the quiz. Like I said, every day we are always updating new things on this platform. This Educate Africans want it to be the leading technology for learning in the whole of Africa. So that's why we are working on it 247 for you guys. Okay. So let's continue. Work, energy, and power. What is work? What is work? Work is a constant term in physics. Most of you have already come across. Okay. So work is done whenever a force moves its point of application a distance in the direction of the force. So whenever you have a force, you see this is my wallet now. Now you have a force coming from my hand, moving this wallet from here to here. That is what work. There is a work done in moving this my wallet from this position to this position. Work. Whenever you move something or you move a load from this point of application to another point, we'll call it work. Work is similar to energy because if I don't have energy, I will not be able to move this wallet from here and push it to this side. So whenever you push somebody that is here, you push somebody, the person falls to a distance, you've done work on the person. Because without energy, you cannot do that. That's why you will normally say work is equal to energy, because without energy, you cannot be able to do work. If you've not eaten and they tell you to go and start cutting grass or go and start doing something, you say that you have not eaten because you don't have energy to do that. Okay? So work is done whenever a force moves its point of application a distance in the direction of the force. That is, force is applied to cause body to move. For a body to move, there must be a force applied. Even you that are moving, if you don't eat, use the force of the food that you've eaten, you cannot move. So very importantly, example, pushing a car to a certain distance. If you push a car, if a car has to move from one point to the other, it has to be by a force, whether it's the force supplied by the burning of the fuel in the engine, or is it being pushed physically by people. So when people apply force, the car will move from one point to the other. So those people pushing that car, they are said to have done a work. Okay. Another way is by what? Lifting a load from the floor to a table. You lift a load. This is your table. This is the floor. You carry this load from here. You move it a distance and keep it on the table. You've done work, because work is simply what done whenever a force moves something from this point of application. Okay. Now let's continue. When no movement takes place after you apply the force, then no work is done. So there must be a distance covered. There must be a movement before you can say that work has been done. If you go there and stay there, no matter the force you have, and you're not able to move a load a distance, you've not done any work. So work is only done when a distance has been moved. Okay. Now, if a force moves a body distance s in the direction of the force, then work is given by is done by the force. Okay. Example, lifting a body. To lift a load through a height edge, a pulling force must be applied to the weight. Okay. When an object is lifted vertically, work is done against the force of gravity. Okay. So this is the formula for work. It is given by force times distance. So take note, work is equal to force times distance. And this is very similar to the formula of energy. If you've worked on energy before, you know that energy is equal to force times distance. So work is also the same thing. So that's why I say that sometimes they use energy in vis-a-vis like what we would have used for force. So if they are asked what is the formula for work or formula, you say force times what? Distance. And that is why in that first calculation for dimension, if you go and check your JAMB question, they'll ask you what is the dimension for work. So they expect you to put this formula and break these things down into the normal fundamental units so that you can convert them to what they should be. So force, what is force? Force is equal to mass times acceleration due to gravity. And distance is same thing as height. So this is the formula you use when you're talking about vertical distance. So this is height and this is what? Acceleration due to gravity. So this is still the same thing as this. So that's why you can say that force is equal to mgh. So that is why force is equal to mgh. So take note. And this is known as potential energy also. And that's why I told you that energy is always almost the same thing as work. Okay, let's continue. So we have different types of energy. You can talk about potential energy, which is energy possessed by a body by virtue of its position or state. So take note, JAMB is going to ask you, what is a potential energy, or what's the difference between potential energy and kinetic energy? Kinetic energy is the energy possessed by a body by virtue of its movement. Whereas potential energy is the energy of a body by virtue of its position, its state. So the energy associated with moving particles is known as kinetic energy, but whereas the energy associated with a body at a given height from the floor, because of that, its position of a ball from the floor, the energy there is potential energy because of position. That's why we call it potential energy is energy of a body due to its position. Whereas energy of this body when it's moving, we call it what? Kinetic energy. So take very important precaution on the difference between kinetic energy and potential energy. So potential energy is equal to mgh, whereas kinetic energy is equal to half mv squared. Please take note, this is squared. Half mv squared, this is kinetic energy, whereas this is potential energy. So example of potential energy here is a heavy stone on top of a table has a potential energy. That heavy stone that is still on top of a table is having potential energy. Whereas that bullet that is fired, that is moving, or an object that is falling under gravity, they have kinetic energy because they are moving. Once they are moving, they have kinetic. But when they are in a position relative to another position, we talk about potential energy. Okay? So with that, we move on to energy. What is energy? So energy is the capacity to do work. Today's lecture, we've already finished simple machine. Now we are into work, energy, and power. We've treated work, we are now into energy. So after that, we'll look at power, okay? So what is energy? Sorry. So what is energy? Energy is the capacity to do work. You can see in the division of energy, there is work. And that's why work is always the same as energy sometimes. So energy is what gives you the ability to do work. Without energy, you cannot do work. So how do you get energy as a human being? You feed. When you eat, you're taking in something. And that's why you're able to perform. I'm able to teach you now because I've eaten. I mean, even now as I'm talking to you, I'm eating up and drinking Coke. So I'm eating because if I don't have energy, I've been working since morning. So I plan my schedule every day is that from morning to evening, I'm working. I'm teaching people physically, but from 6 o'clock to 8 o'clock, I'm teaching you people online. So I'm doing another work. So I have to eat always, make sure that I have enough energy to burn. If not, I'll be tired and I'll be exhausted. I will not be able to teach you. So energy has a lot to do with work because energy is my capacity to deliver to you. If I don't feed very well, I will not be able to teach you well. So energy is the ability to do work. So anything that is capable of doing work has energy. So anybody that is capable of doing work has energy. Without energy, you cannot do work. Example, a person pushing a car has energy. A student running around a field has energy. A mango fruit falling from a tree has energy. So what are the forms of energy? We have what we call mechanical energy, heat energy, light energy, chemical energy, electrical energy, atomic energy, solar. All these things are energy, solar energy. So if you are to, without solar energy, you will not be seeing the solar light. Without atomic energy, people that like in Japan and some other countries, they are using what we call radioactive energy to power their everything there. So they use a lot of atomic energy. Without electrical energy, you cannot iron your clothes, you cannot watch TV in the house. Without chemical energy, you cannot eat the food. The food that you're eating is a form of chemical energy, supplying you energy to do other things. Without light, you cannot see the light energy. Without heat energy, you cannot be able to boil your water and cook in the house. Without mechanical energy, you cannot be able to move your car and do other things. So all these forms of energy are very, very important. And finally, let's look at the last concept, which is the concept of power. So power is the time rate of doing work. So how much work are you able to achieve over a specific period of time? That is power. So if you have more power, that means you can deliver more work. within short period of time. So power is the rate, time rate. It measured in time rate of doing work. So the energy or work expanded all over time gives you power. Very important. So energy or work all over time gives you power. So we're going to be taking an example. A body of mass 10 kg climbed up 10 steps each of height 0.2 meter in 2 seconds. Calculate the power of the boy. Okay. So power is equal to always work over time, and work is equal to what? mgh over t. We already know that work is equal to mgh. So we'll now multiply out. M is mass 10, is given here 10 kg. G is acceleration due to gravity 10, and h is what? 0.2. That's the height. All over time is what? 20 seconds. To multiply out is going to give you this. Now, work energy resources. Renewable energy are those that can be replaced. Okay. On a larger scale, you can be looking at what we call renewable energy, which are energies that can be replaced. Example is solar energy. Solar energy is an example. That's why when you're hearing about green energy, Nigeria is moving towards green energy, solar energy, wind energy, because fossil fuels, they can deplete over time. Water energy, biomass, all these are examples of what? Renewable energy. And biomass can be gotten from energy from garbage, sugarcane, and seaweed. Whereas non-renewable energy are those energy that cannot be replaced. Example is petroleum. That's what we are using in Nigeria, natural gas, coal, and wood. So we don't want to be using non-renewable energy. We want to be using renewable energy. That's where technology is moving towards. So formula for work is also Fs in joules, okay? So yeah, I think this is okay. Galaxy A01, what's your name? Unmute yourself. You're on mute. I cannot hear you. Do you know how to unmute yourself? Are you using a laptop or phone? Click on unmute so that I can hear you.
I'm happiness, sir.
Yeah, happiness. You're copying.
Yeah.
I like what you're doing. You're a serious student.
Yeah, I need to focus. I don't have much time again.
Yeah, you don't have much time. Good.
I don't have much time. I really appreciate this, sir. I really, really appreciate it.
Okay. Thank you. I like the fact that you're putting effort. I like students that put effort, that note, and try to improve.
Thank you, sir.
Yeah, thank you. Okay. So let's quickly go to, like I said, you guys are going to try out this quiz. Click on it and answer them. That's your assignment. And I'm going to be checking it out for everybody. Happiness, have you registered on the website as a student?
No, sir. I tried to register, but I don't have email, sir. I have only Gmail.
Yeah.
But it's not responding. Only Gmail.
Gmail is okay. It's okay for it. Gmail is an email. Use your Gmail. It's okay. Try it again after now.
Oh, okay, sir. Okay, sir. No worries.
Yeah. So I'm going to click on the next topic, which is Centrifugal and Centripetal Force. Okay. So you guys can see how fast we are moving because of this platform. That's why I want to be using it. If we don't use it, we are going to take so much long time. We might not cover our syllabus. So that's why we're using it. We want to move very fast. In a day, we also will be able to cover like 3 to 4 topics, and we'll be moving. Okay. So let's look at centripetal, centrifugal. And like I said, most of the topics, all of them have video tutorials. So as you're checking through the notes, you're listening to the video. That's if you're studying on your own. But when I come to class, I'll use the text-based to study. These last 4 courses that I've not done videos for them. That's why we're using the text only. But anytime I'm also teaching you, I'm going to be using text-based only. Since the video format, you might not be hearing it when you're following me here. But when you play it on your own, you'll be able to hear it clearly. Okay. So let's look at centripetal and centrifugal forces. Okay. So what is centripetal force? It is the inward force required to keep an object moving with a constant speed in a circular path. Whereas centrifugal force is the equal but opposite force that a stone exerts in a string due to Newton's third law. So whenever you hear centrifugal, when you're swinging something, let's say you have let's say this is a rope. Then you come and tie a stone here. This is a stone tied on this rope. Then you hold this rope here, you start swinging it. So as this stone is moving like this, as you're swinging it, so the force that is keeping this stone revolving, not going out, but to keep revolving in this circular path, that force is dragging it towards the center of the circle. So that inward force that drags it towards the center so that it doesn't break away and go and hit somebody's head, that force is known as centripetal force. Whereas the opposite force that is trying to make it to break away is known as centrifugal force. So take note of these two forces. Very, very simple. When you're swinging something, something is moving in a circular path. You understand? That force that is holding it, that is towards the center of that circular path, is the centripetal force. Whereas the opposite one is the centrifugal, and it's given by mv squared over r. Take note, mv squared over r. Please, when you're using this material, you're gonna be seeing some mistakes on putting squares and all those things. But that's what we are currently working on, because this is a very new platform. You're updating them. You see some mistake today, next time you go there, you're not gonna see it again. Okay. So let's move forward. Angular speed and velocity. Now consider the speed of a stone when it is whirled on the end of a string. This is what I just explained. The stone that is tied at the one end of the rope, you call it string, and you're whirling it. You understand? So consider the speed. The stone moves in a circular path. Then angular velocity is defined as the angle turned through divided by the time elapsed. So that angle turned through divided by the time elapsed is the angular velocity. So it can also be given in this form, which is the normal velocity over the radius. Now, application of circular motion, road banking for turning of a road. So very, very important. There's what we call banking of a road. Like any road that you know that people are going to have a turn, a sharp bend. That road shouldn't be a flat. It shouldn't be flat. It should be banked a little bit so that people will not fall off when they are turning. So take note. So centripetal force is defined as the inward force required to keep a body moving with a constant speed in a circular path. I've said that before. And centrifugal force is the opposite force. Okay. Okay, so those are the two explanations for those two forces. Let's move forward. So lastly, for today, we're going to be looking at elasticity. And the elasticity is not going to be a note, it's just the quiz.
Okay.
Happiness, you're now on mute. So when you say your disturb the whole class.
Oh, I'm sorry, sir.
Okay, so let's quickly look at elasticity. Okay, so like I said, elasticity is it's just the past question now and the explanation of the past question. Okay, I would rather go to the explanation of the past question since I expect you to do the quiz. So let me click on this explanation. So make sure you're using these resources straight to what you want. Okay. Okay, so we have just two things there. A 10-gram mass placed on the, oh, these are very too tiny. Happiness, you're squeezing your eye to see it, but okay.
Okay, sir.
What I'm gonna do is that I'm gonna leave this at this point. I'm gonna expand this. We're gonna put a better scanned work so that you guys can consume it well. So this is just one question, two questions, and they're very simple to solve. So in the next class, we are gonna be solving it when I must have made this to be bold enough. Okay. So for those of us that are joining us just now, like Chika, I'm gonna go through the process of what I thought when I started. So how did we get to this website? We just simply came here and we typed Educate Africans. Like I said, this is the website. This is where we are working. This is where you're going to get everything you need for you to score your 300 and above. So once you get to your browser, just go to Educate Africa. This is the website. It just opened. Okay. So once it opens, for those of you that have not registered as a student, this is where we have the student registration. Go click here. It will show you what to fill in, your email and other things. Why is good you register so that when I give an assignment, you'll be able to solve. And when you do the assignment, I will see it. If you have questions and to ask me, there's a Q&A section in your profile where you can ask your question. My teachers that are working with me, they will see those questions and help you sort them out. You can just snap your question, write it on a paper, snap it and put it inside that place. So many ways of getting there. Okay. Then when you get down now, you see all the subjects. This one is CRS, Christian Religious Knowledge. This one is literature. This one is commerce. This one is economics, English. So when you scroll down, you might not see what you want. You have to click on view all courses so that it gets you to everywhere. Another way of getting to all courses is by when on the menu you can see all courses here. You click on it. So once you click on it, it will now open up the whole of the courses that we have. If you scroll down, even if you don't see the course you want, there's a next button there. You click on that next, it will take you to all the courses, okay? So I clicked on all courses. Now it's gonna open up all courses so that I will see the rest of the courses. So like I said, once I'm done with this class, quickly go to the quizzes, answer the quizzes, so that if there are issues with them, you let me know in the question and answer Q&A section, so that we have to update it. Like I said, we're constantly working on this.
Sorry, please, another topic.
Yeah, Chika, come again. I didn't get you.
The quiz you gave us, is it the one under elasticity?
The 4 topics we just treated now. Number 1 is simple machine. There's no quiz on that one, but there's mechanical work, energy, and power. What's it called? Those 3 topics we just treated now. Those are the quizzes that you guys are supposed to do. Okay. So when you get to here, this is the physics, the one done by Zimos or Zechina. That's the one we are working with. Click on it. So once you click on it, it will open up. Okay.
Okay. So it's only the one under elasticity.
Yeah. So once it opens up, these are the lectures. Now you can start taking them. If you click on this one now, you start taking lectures, both the video lectures and every lecture. Dimension, units, vernier caliper. If you don't know how to use vernier calipers to measure micrometer screw gauge, click on any of these. You see me explain them in video format very, very clearly. Motion, types of motion. We've done all this already in this our online class. Equation of motion, vertical projection, resultant velocity, force, electric circuits. Those are the ones we'll be learning by next week. Current, electricity, resistors, series and parallel resistors, electromotive force, Ohm's law, measurements of resistance, potentiometer, electricity calculation, capacitors, factors affecting capacitors, stance of a capacitor, electric field, work done in a capacitor, energy stored in a capacitor, determinate. You see all these things, I've done them in video format. I lecture them. Took me years to do that, but perfect lectures for them. Go through them. Electric cells, simple cells, Daniel cells, Leclerc cell, primary and secondary cell, lead accumulator, gravitational force, light propagation, rectilinear transmission of light, waves, waves calculation, sound waves, echoes, the rest of them. So for Chika that is asking question, if you scroll down, these last 4 topics, that's what we did today. So do the quizzes on these last 4. So this one does not have, but this last 3 has. So I'll be checking it out. Once I log in, every student, once you've registered as a student, once you attempt any quiz, I'm seeing it from my own side. So by that doing, I can be able to monitor your progressions. Okay. So very importantly, and very make sure you register as a student. Then when you open up a course like this, if you come up here, you see where this place that we have Facebook logo. Click on it, share it on your Facebook so that your friends and family can see them and be able to use this work. This work is specifically meant for people to score very high. So always share our lectures after having it. If you think that they are good, share them. And if you watch out on YouTube, you like our videos, always give us a thumbs up. It's good for us. Thank you and see you when I see you. Yeah, any questions?
Hello, sir. Can you hear me?
Yeah. Happiness.
When next are we having a class of chemistry, please?
Chemistry, we're having chemistry tomorrow. It's like you're telling us for the first time. Every day by 6, we have a class. We have chemistry tomorrow. Next tomorrow, we have English. All your JAMB subjects, we are going to be taking care of them. On Thursday, we have mathematics, and on Friday, we have biology. So every day by 6 o'clock this time around, get ready, have your notes beside you. We have a very interactive good class. Then we'll give you an assignment. Once you're doing our assignments and taking our classes, the sky is your limit.
Okay, thank you, sir. I really appreciate
that.
Yeah. Thank
thank
you.
you. See you when I see you, everybody. Thanks for
Okay.
joining. God bless you all.
All right. Have a night.
Thank you, sir.